Okay, so I'm just going to go over the solutions here to the second half of the Unit 1 exam review. So questions 7 through 10. The first question here, probably not much to discuss. Basically, a logarithm is an exponent rewritten. And so when I'm asked to evaluate one, I can either punch it into a calculator, which is what happened for C and D here. Anytime you see something like this, we punch in log of the big number divided by log of the base, and that gives us our solution. We can do this over here if we want to, and if we were going to do that, we would treat it as log of 1 divided by log of 10, because the base here is 10 when nothing else is written. And so doing this, we end up with the same answer. But again, rearranging this, we want to recognize all of this is equal to something. So in this case, x can be used to represent that something. And that is our exponent. The base is 10, as we stated. So 10 to the x, base 10 to the exponent x will be equal to 1. And then however we choose to rearrange that and solve that at that point is up to us. If we write the two terms with the same base, 10 to the x and 10 to the 0, that means that x must be 0. Again, punching that into a calculator, if I ran into this question somewhere along the way of a word problem, just punching it in gets me that same answer. Same sort of thing here. I can rewrite it if I choose to. This is my base, this is my exponent. The whole thing is my exponent, so the whole thing is equal to x, my exponent. And then 3 to that exponent will be this value. And again, the question's asking me, what exponent on 3 gives me 729? And so I can figure that out either by trial and error or by, over here, just punching it into the calculator. Question 8 is essentially the same. It's asking us to rearrange, though, from the exponent form to the log form and then solve it that way. And so we want to remember that when the reason we have logarithms is to find the exponent. So I use it in a situation like this where I have an unknown exponent that I can't figure out, sort of by trial and error or by being logical. 10 to what exponent equals 15? I don't know. And so when we rearrange it, the x is isolated. The purpose of the logarithm is to isolate the exponent. And then log, the base of the original question, is the base now of my logarithm. And of course the other value is just kind of that last value off to the end. Punching it into a calculator again is log of the big number 15 divided by log of the base, which was 10, and we get 1.1761 approximately. Well, that's a pretty poor approximate. Same sort of thing for the other two. Okay, so 8 to the x, rearrange, we're isolating the x, equals log, the base was 8, the base of the log is now 8, and then the 3 is isolated. So again, punching it into the calculator, log of the bigger number divided by log of the base gets us our final answer. Question 9 is asking us to find the number of mutual funds based on this equation. Okay, so the rest of the question doesn't matter too much. What we're finding is not too important. I have this equation and I'm asked to make use of it. When will the number of mutual funds reach 10,000? So when will M be 10,000? 10,000 gets substituted in for M, equals, and the rest of the question looks the same. And now, of course, we have an equation to solve just like any other we've ever done. I have a multiplication here. I'm trying to isolate my n, remember. And so I have the expression involving n times 460. I don't want that 460, so I'll divide by 460. And of course, if I divide one side by 460, I divide the other side by 460 as well. And so I end up at that point. 10,000 divided by 460 is approximately 21.73 and so on. And now again, exactly the same as what we had above. We're trying to isolate our exponent n. To do that, we use logarithms. The base is the 1.19 here. It's the base of the exponent, or the exponential part. It's the base of the logarithm as well, and the 21 point is the rest of it. And then again, log 21.73913 divided by log 1.19, and we find that n is approximately 17.7. And so that's saying 17.7 years later, after the original part of the question, the 1989, is when we would hit that mark. And so adding 17.7 to this, we get something in sometime in 2006. The second part of the question, how many years will it take for the number of mutual funds to triple? And so if we start with 460, when it triples, we get to 1380. And so 1380 is my ending value. It's my M. It's the number that we have. The 460, of course, was the initial value that was in the original question. And the 1.19 is what's going to allow me to grow. And now again, same sort of thing. Of course, we got this number by multiplying 460 by 3. So when we divide by 460, we get back to that same 3. And then solving it as we did last time, log of 3 divided by log of 1.19, we find that n is about 6.3. So it takes 6 1/3 years almost, so 6 years and 4 months approximately. Okay, so number 10, radioactive tritium has a half-life of 12 years. We start with 1,000 grams. Here's our equation. How much is left after 100 years? And so we're looking for the amount, the mass that's left. So basically, starting with this equation, we're given the 100 years that goes in. And so that's pretty much just use the calculator, and we find that M is approximately 3.1 grams left. The second question, how long does it take until we only have 100 grams left? So that becomes our mass now. The rest of the question, of course, is as it was. And as we did for several questions now in a row, divide through this number, so we get 0.1, take the logarithm. Kind of skipped the one step here, which is just rewriting as t is equal to log base 0.9439 of the number 0.1. So I ran out of room, but essentially that's what I'm trying to do. To do that, I do log of the top and the big number divided by log of the base, and we get approximately 40 years.